Hello guys, welcome back to Math Zone African Motives. We are still on our analytical geometry, and this is a continuation, which is actually a follow-up exercise from the previous introduction that we had. So make sure that you watch the introduction so that you will be able to understand actually what we are going to be referring to in this exercise. We are given in this figure below, that is the one that you're given on this diagram. We are given the point L, which is -2, -1, the point M, which is 4, 3, are the vertices of triangle K, L, and M. These are the points X, K is the point XY, which is the one that you're given there. Then we are given the equation of KL. All right, this line KL, we are given its equation. Let us just save this. Maybe you can understand each other. Let me just try and have this way. So there we have got the equation of this line. That is y is equal to 5x plus 9. There's something important that you need to notice, or that you need to note whenever you are given an equation. All right. Also, you are given the equation of Km. This is our Km, which we are given as 5y plus x minus 19 is equal to 0. All right, so equations can be also written this way, guys. It's like I'm having an equation like this. Maybe y is equal to minus 3x plus 5. I can choose to write this way, this side, transpose everything this side. So it's going to be y plus 3x transpose the 5. It will be a -5 is equal to 0. So don't be scared about that equation, the format that you have there. This part we can even make y the subject. You can write the way that you want. All right, let us see this. 5y plus x minus 19 is equal to 0. We can even transpose those numbers back to where they were before. To the right-hand side, this will be a negative. To the right-hand side, this will be a positive. So meaning to say 5y is equal to minus x plus 19. Remember, say this is going to be a positive. So if I am to divide by 5, by 5, by 5, each and every term y is going to be, this is minus x over 5. There is a -1 there. So it's the same as -1 over 5x plus 19 over 5. Guys, it's up to you. The way that you solve an equation, I mean, the way that you want your equation to be written as, it's up to you. It's up to you the way that you want this to be written as. All right. So this is not part of our question. I'm just saying. So it can be written as y is equal to minus of x plus 19 over 5. So I'm not saying you're supposed to, whenever you see this, you write this. No. I'm saying it is the same thing. Don't be afraid. When you see this format, is still one of the same format as you are used to before. All right. So let us answer the first question. Show that the coordinates k is given as -1, 4. K is this point, and k is the point of intersection of the two lines. So it follows that we never talked about this in our previous class, but let us refer to this. It follows that whenever you refer to the point of intersection, the point of intersection is the one that you have when two lines intersect, when two lines meet. If you're given two lines, they do meet at a certain point, which is referred to as x, y. Remember, a point is always x, y. So to have that point of intersection, you simply have to solve the given equation simultaneously. Solve. All right, so just solve the given equations simultaneously. Meaning to say we are back to our simultaneous equations. Remember, in simultaneous equations, you'll be given two equations, then you're asked to solve simultaneously. The same way that you're solving those simultaneous equations, you're determining x and y at the same time. That is the same way that you're going to have. So in this question that you are given on number 1, we are asked to show that k is -1, 4. So this is what you're given on question number 1. We need to show that k is -1, 4. So this is our point k that we need to show this. So how can we show this? Remember, we are given the two equations there, the equation of this line and also the other line, km. So we can solve these simultaneously. We have the equations of the given lines. So like I said, you can solve them simultaneously. The first line is given as y is equal to 5x plus 9. Remember, from our line KL, then also the line KM, we are given this as 5y plus x minus 19, which is equal to 0. So we are going to solve these two equations simultaneously. Meaning to say I've got the first equation and I also have the second equation. So taking advantage of the first equation that y is already the subject of the formula, y is written in terms of x. So what I can just do is to substitute equation 1 into 2. All right, by using substitution method, I'm going to substitute, all right, equation 1 into 2. So in short, that's equation 1 into equation 2. So that is y in place of what? Where there's a y there, you're going to substitute what is represented there in terms of what? In terms of x. Remember that we are given that y is equal to 5x plus 9. This part here is the one that you need to substitute where there is a y in the second equation. All right, so let us consider this. That is going to be 5 times. In place of y, you're going to substitute 5x plus 9 plus x. X is, there's nothing to be substituted for x. It is the part of y that is affected. X remains as it is. It is not affected. All right. So that is minus 19 is equal to 0. So expand by 5. What are we going to have? That is 25x plus 5 times 9, which is 45, plus x minus 19 is equal to 0. So solving this equation, we can see that we've got like terms, the part of x, the part of x. So we are going to collect the like terms. In this case, this is the same as there is a 1x. So let us add 25 plus 1, that is 26x. Okay, the part also of these numbers, you can subtract 45 minus 19, that is going to be a positive 26, and this is that is equal to 0. So transposing a negative, the positive 26 is going to be a negative 26 on the right-hand side. So this will be negative 26. So let's divide, guys, by 26. Let's see what are we going to have at the end. Our x value will be a negative 1. So that means we can determine the y value by substituting in any of these two equations. In any of these two equations, but I can take also advantage of the first equation because already y is the subject. Y is equal to 5x plus 9. So I can simply substitute the x value and determine the y value. So that is 5 times x. Remember, our x is negative 1 plus 9. So that is going to give us a positive 4 at the end, minus 5 plus 9. That is a positive 4. So as you can see, that's exactly the k that we wanted, in this case, minus 1, 4. The x value to the y value. So this is what you're being asked to show. So that is exactly what we obtained there. So be careful. So this one is fine. So meaning to say our k here is minus 1, 4. That is what we have at point k. All right. So just for the sake of having our persons next to the diagram, let us just remove this. I just hope we are clear on this one. So let us revise as much persons as we can. Maths is not that difficult. If you are someone who is working this on a daily basis and also doing question papers after each and every introduction, you do revisions on question papers, you see that maths is not that difficult. It is just a repetition. It is just a follow-up. It is just something that is just like a pattern. It's just like art, you see? So the more you revise, the more it becomes part of you. That's it. Determine the equation of the median Kn. What is a median? That is the question. Of triangle KLM, express it in this form, which is the format of y is equal to mx plus c. We talked about this, which is the gradient intercept form. We need the equation of the median Kn. This is k to n, this one. K to n, the equation of this line. So what is happening is that n there is the midpoint. For this to be a median line, a line which divides this triangle into two equal parts, it means that this point N is the midpoint. So meaning to say it is drawn to the midpoint of line. It is drawn to the midpoint. It is drawn to the midpoint. That is the median concept. So if it's drawn to the midpoint, I simply have to determine, because I have the point K, remember, is the one that we proved here. So what we simply need is to find N, which is the midpoint. So that's the case there. All right, 1.2. So like I said before, N is the midpoint. So to determine N, which is the midpoint, you are going to use the midpoint concept. Okay? So remember from our midpoint concept, how do you determine this? So you can write N is equal to, or you can write N like this, representing a point N, or you can write N is, guys, no matter the way that you, as long as you understand what you are doing there. So N is the midpoint of what? LM. These are the 2 points which lies on the line where N is. So remember from the midpoint concept, you said it's going to be x1 plus x2 into y1 plus y2 over 2. From the given points L and M, we can use these 2 points as our midpoints, depending with the way that you're going to name your points. You can have this as x1, y1, this as x2, y2. So that means N can be given as x1, that is minus 2, added to x2 on this point, which is 4 over 2. Then the y value, which is minus 1, plus the y value on this point, which is 3, everything over 2. Like I said before, the way that you're going to name these points depends with you, as long as you understand that you are having the x values on their own, the y values on their own. So this was going to give us a 1, 1 on our calculator. So that's the point N is there, which is our midpoint. So with N as the midpoint and with the K, we can, because we need to determine the equation of Kn, and we have the point K. So given the point K, which is minus 1 for the one that you're given there, the one that we proved before, we have the point K, we have got the point N. We can determine the equation. Remember, the question there is for us to determine what? The equation. So how do you determine the equation given points? That is the question. When given 2 points, we can determine the equation. Remember the concept? You are back again to that gradient concept. You need the gradient first. So the gradient of Kn, remember the change in y over the change in x. So depending with the way that you are going to name your points, maybe you decide this to be your first point, this to be your second point. It's up to you. X1, y1, x2, y2. It's up to you. So this will be y2, which is 4 minus y1, which is 1 over x2. That's minus 1 minus x1, which is 1. So you are going to determine or have the gradient of the line, that is 3 over minus 2, which is same as minus 3 over 2. With the method that you're going to choose, I don't know which method I'm going to choose, but you're going to have the answer in this format at the end. So if you are already given this format, I guess it's best that you also follow suit the format that you're given. Y is equal to mx plus c. Just substitute. Remember, m is the gradient, and we calculated that minus 3 over 2x plus c, which is the value to be calculated from any given point, like I said before. So I can choose to use the point N is the easier, guys. There is 1 and 1. There's a negative there. Just choose what is easier for you. All right. So you can choose to work with the point N. Any part, I'm not saying it's difficult, but any part is just choose to work with what is easier for you. So I'm going to use the point N, which is 1, 1. That's x and y there. So y is 1. When x is given as what? When x is given as 1, you substitute into the equation. Minus 3 over 2 times 1, that's minus 3 over 2. We transpose it to this side. It becomes a positive because it was negative. The moment it crosses, that's a positive there. So C was going to be 1 plus 3 over 2. You're going to obtain 5 over 2 on your calculator. So that's the value of C. So having the value of C, therefore our equation was going to be given as y is equal to, we substitute back to this part that you have already, that is minus 3 over 2x plus c, which is 5 over 2, in exactly the format that you are given to express your answer as. There is a format there. You have a format that you're working with. Maintain that format. You have to maintain the given format there. So that was the equation of the bisector, which is this one. So let us just write it aside. We might need this. Like I said, guys, I just need to erase this so that we take advantage of this space that we have here. So we calculated the equation of Kn. This equation was equal to y is equal to minus 3 over 2x. This is minus 3 over 2x plus 5 over 2. Remember? Still remember that is what we got there. My memory serves me very well. All right, so this is our equation. We might need this. We do not know. So let us just leave it aside. Find the gradient of Lm on 1.3. So 1.3 is a direct question. The gradient of Lm. Are we having the point L? Are we having the point M? The point L is there. The point N is there. So this is a very, very direct question. Remember, our gradient is just the change in y over the change in x. All right. So you can even write it as Lm, like Lm. So this is the gradient of Lm, which is y2 minus y1. Already we stated this x1 before, so it's going to be y2, which is 3 minus y1 there. That is minus 1 over x2, our x2 value. That is 4 minus x1, which is minus 2, according to the way that I mentioned my points. I indicated my points there. The way that you mention, the way that you indicate your points determines how you're going to substitute them on the formula. That is the idea there. So that was going to be 4 over 6, which is simply 2/3. So you can just save your own it on your calculator direct like that. That is the idea there. So just remembering that your question is to calculate the equation, you can now determine, the equation, if you're given that consideration. So this one, it was just a gradient. Okay, so you're done on that one. All right. So this one, let me just rewrite it here. Sorry for that. So you see, guys, these softwares, how they do react. But anyways, we just hope with time we'll be together. So the gradient of Lm, that is, we got 2 over 3. So we are going to see, maybe we might need that gradient later on. 1.4, then it's a continuation, meaning to say we're going to need that one. Then it's a continuation from whatever that we did before. So then prove that Kn is the perpendicular bisector of Lm. All right. Before we did, we talked about this. Remember, Kn, this is our Kn, guys. All right. This is our Kn, this one. Remember, before we said N is the midpoint, remember. But here they're not only about to be a bisector. To bisect, guys, it means to divide into 2 equal parts. That is to divide. That is to bisect. To divide into 2 equal parts. But this is not about just bisecting. It is a perpendicular. What is it there about being perpendicular? Being perpendicular means they have to meet at 90 degrees. So it's no longer about just being a bisector there. Understand your question. So the midpoint or the bisector part, we are not focusing on it. No, we're not focusing on that. Because already we're told that this is the median Kn, and we say this is the midpoint. So now they want us to prove that this line Kn is at 90 degrees. That is what they want you to prove. Because the bisector concept is done. It's done. The bisector concept is the one that we had before the midpoint concept. So we need the perpendicular part. So what is going to be it now about being perpendicular? All right, that's 1.4. So for these 2 lines to be perpendicular, remember what I said on the introduction, that 2 lines are supposed to be perpendicular if the gradient of the 2 lines is equals to -1. That means what we need to prove is, in this case, is that line KN and LM. So meaning to say the gradient of KN times the gradient of LN, which is LM. That line that you're given is LM, should be equal to -1. This is what we need to prove. If we can prove this, then we are done. All right, so let's see. We have the gradient of Kn. The gradient of Kn, are we having this? Where is our Kn? This is K to N, this one. Remember when we calculated this equation here of Kn, we had the gradient, it's only that I erased. But for this one, we can even take it here on Kn. This was our gradient, the one that we calculated. Remember, it was -3/2. So meaning to say, -3/2 times the gradient of Lm. The gradient of Lm, that is 2/3. All right, so if you had to use this on your calculator, if you had to use your calculator, that was going to give you a -1. So as we can see, we are obtaining a -1. To obtain a -1, thus, therefore, these two lines are perpendicular. So therefore, Kn is perpendicular to Lm. All right, that is it. That is to say, Kn is not just a bisector, but it is a perpendicular bisector. It bisects this line at 90 degrees. That is being perpendicular. It bisects at 90 degrees. That is the idea there. All right. 1.5, what can you deduce about triangle KLM without further calculations? What can we say about triangle KLM? This is our triangle KLM. What can we say? All right, we saw that this is at perpendicular, it's at 90 degrees, bisecting this line into two equal parts. There is nothing but it is an isosceles triangle. Remember the isosceles triangle concept. This is the idea there. The isosceles triangle concept. I'm not saying it can be also an equilateral triangle. So what is important is that if a line is drawn from one point, which is the vertex, bisecting this other line that is at perpendicular at 90 degrees, bisecting this line into two equal parts, it follows that these two lines are equal in length. So if this line, and also this line are all equal, it becomes an equilateral triangle. But if it is only these two lines which are equal, but they are not equal to this line, then it becomes an isosceles triangle. So we can't say it's an isosceles triangle, or we can't say it's an equilateral triangle, but we can deduce that. That is the idea there. So 1.5, we can deduce that this is what we have from K to L. This line is equal to K to M. All right, so we can deduce that KL is equal to KM. That is the idea there. So be careful on your presentation. That is what we have. 1.6, if L, M, and the point J given as 7P are collinear. Remember, I talked about the collinear points on the introduction. Calculate the value of P if these points are collinear. All right, let us have it here. I hope you understand me on this one. That's 1.6. So we are given the point L, the point M, and the point J, which we do not know, or that we are not even having on the diagram. We do not have that. But L and M are the points on the diagram. The point L is given on the diagram. This is -2, -1. That's our point L. And also the point M is there on our diagram, which is 4, 3. So what is it that we can check about the collinear concept if points are referred to as collinear? It means that They lie on the same line. They have the same gradient. If I'm to consider any point, the gradient of LM, these 2 points, must be equal to the gradient of MJ. In that case, it must be equal to the gradient of MJ. All right, the gradient of M to J. It is also supposed to be equal to the gradient of LJ. Whatever way that you are going to, as long you are taking 2 points. So taking that as an advantage, because we have the gradient of LM. The gradient of LM here, we calculated it before, it was 2/3. So we have the gradient of LM before, which is 2/3. So what we need there is, in order for us to have the value of P, this one, we are going to use the point J, which has got P. That's where P is. P is on the point J. So you're going to take any part that you want. Is it M and J? Is it L and J? It's up to you. So in this case, I'm going to use M and J to find what? The gradient. So I'm going to determine the gradient of MJ. All right, remember the gradient change in Y over the change in X. That is our gradient concept. So using MJ, that means I'm going to refer to this M as X1, Y1, this as X2, Y2. It's up to you how you're going to name it. So Y2 is P. That is going to be P minus Y1, which is 3, everything over X2, which is 7, minus X1, which is 4. So this is going to be P minus 3, everything over 3. So this is the gradient of MJ. So knowing that these points are collinear, they are on the same line, they have got the same gradient, I can equate these 2 gradients together because I understand that they are equal, these 2. So it follows that this gradient of P minus 3/3 is equal to the gradient that we numerically have of LM. That's a numerical value. This one, it's in terms of P. So from this, you can solve for P. That's an equation now. You have an equation. So how are you going to solve for P? It's either you're going to cross multiply, it's up to you. But if you can check here, the denominators are the same. So if they are the same, you can take it as an advantage, guys. This concept here that I want you to understand. Now we are at a higher level. We could have talked about this in grade 11, but now in grade 10, but now you can understand me, guys. It follows that if the denominators are the same like this, you are solving an equation, just equate the numerators. So it means, therefore, P minus 3 must be equal to 2, since the denominators are the same. So that means P is going to be equal to, I transpose this, that will be 2 plus 3, which is 5. So what am I trying to say? If I am given an equation like this is X plus 3, everything over 2, and we are given this as 7/2. Instead of you to cross multiply, yes, you can do that. But instead of you doing that, because the denominators are the same, you can take advantage whenever it is like this. You can take advantage of this. You just equate the numerators. So it follows that X plus 3 will be equal to 7. Transpose this. X is going to be 7 minus 3, which is a 4. That's the idea there. So meaning to say we can solve any equation as long the denominators are the same. So we have got ways, guys. So I want you to do the cross multiplication and prove if we are in the same direction. So that is the value of P. Let us remember this in case we are going to need this. Let us just remember our value. All right. Let us consider 1.7, the coordinates of the point Q, which is going to make this whole part of KLQM a parallelogram. All right. The coordinates of Q, let's check where are we having these points, K, L, whatever that we have there. So this is where we have our points, K here. So whenever you are given this, you are supposed to follow suit the order that you are given. The order that you're given is important. You need the coordinates of Q. You do not know about this point Q, so you can just call it XY. But it is supposed to form a parallelogram, which is referred to as K, L, Q to M. So I am supposed to follow the order from K to L. That means there's a point Q somewhere there to point M, so that I'm going to form a parallelogram, something like this, where these two sides are parallel to each other and also equal. These two sides parallel and also equal. And it also follows that if this is my point Q here, which is referred to as XY, the midpoint, which is our N, is going to be common. Remember, N is the midpoint of LM. LM is going to be a diagonal. We have a diagonal there. Remember the concept about a parallelogram. We're back now to the properties of your shapes from your grade 10. From our grade 10, we said these diagonals of a parallelogram, they bisect each other at a certain point. They do bisect each other, meaning to say this point N is the common midpoint. So N is the common midpoint. It is going to be the common midpoint of the diagonals, of the given diagonals, of the diagonals. So what am I trying to say? If N is the midpoint of the given diagonals, and we have that point N, remember N is given as 1, 1. It means we can use the midpoint concept to calculate the point Q, because this K to Q, it is a line which passes through the point N. It's a diagonal, and it passes through the N because the common midpoint for the diagonals. So meaning to say it is also the midpoint of what? It is the midpoint of K to Q. Why am I consider K to Q? Because that is where I am supposed to calculate the value of X and Y on point Q. So using that, let's say we have got the midpoint of KQ. What is going to be the midpoint of KQ? The midpoint of KQ, remember the formula, x1 plus y1. So it's going to be the x value to the x value on the other side. So let's say we've got x plus minus 1 over 2. The y value at this point, Q, which is y, the y value at this point, which is 4. So this is y plus 4 over 2. This is what you were supposed to have, y plus 4 over 2 as your midpoint in terms of what? In terms of x and y, the ones that you're given. The same midpoint is the same as this one because we said it is the common midpoint. So if it is the common midpoint and I can write the same midpoint in terms of x and y like this, and I want to calculate the value of x and the value of y, I can simply equate because this is the x value, the y value, the x value, the y value. So it follows that the x value at the midpoint must be the same. There is no way that n is the midpoint, which is 1, 1. Then we calculate the midpoint of KQ, which is a diagonal, because we are saying it is the common midpoint of the diagonal. We calculate the midpoint of this diagonal, we get something like 1, 3. It's impossible, while this is 1, 1. We are supposed to have the same value, the same. If we calculate the midpoint of this, it is supposed to give us 1, 1. So it means this is equal to 1. This is equal to 1. That is what it simply means. There's no way we can have different values of x at the midpoint. While we said it is the common, it is the same midpoint. It can be. So it means that this one for x, all right? So considering for x, this one must be equal to the part of x here, which is x plus and minus, that is a minus over 2. We have formed an equation for x. The same thing for y. If we are to do this, we are going to equate and form an equation there. So for y, we are going to take the y value at the common midpoint to the expression or to the presentation of the y value of the same midpoint in terms of what? In terms of y. So with this, we can solve the given equations. Solve the given equations. So in this case, we are going to solve our equations. This is 1 over 1. So remember, I said you can make the denominators to be the same, but if you do not understand that, on this case, they are different. So just proceed with your cross multiplication, or you can write this as 2 over 2. Then you equate the numerators, or you can just cross multiply. 2 times 1, that is 2 is equal to 1 times anything. It remains as it is. Transpose the negative 1, it becomes a positive. So 2 plus 1 is equal to x. So that's x is equal to 3. So like I was saying, you could have written this 1 over 1. It is the same as 2 over 2 also. To get a 1, we just need a 1. So 2 over 2, why 2? Because we want the denominators to be the same. So 2 over 2 is equal to x minus 1 over 2. By having this, I simply understand that if the denominators are the same, also the numerators are the same. So meaning to say I can transpose this, and 3 is equal to x, just like this part. So you could have taken it that way, or you can just apply your cross multiplication because the denominators are the same. Or even if the denominators are the same, cross multiplication can be used. So 2 times 1, that is 2, is equal to 1 times anything, remains as it is. So let's transpose the 4. This side, it becomes a negative 4. So that's it. Y is equal to 2 minus 4, which is minus 2. So meaning to say that the point Q that we do not know about, which is xy, is or can be written as x, which is 3, and the y value, which is minus 2. Remember, a point always is written in terms of x and y. So that is our point Q, which is 3 minus 2. So this is 3 minus 2. Just like that, okay? So that's how you play around these typical questions. Yes, sometimes you just have a lot to go through in your revisions to master up these typical questions. But as I said, maths is not that difficult as long you master up your concept, then do as many questions as you can. You understand this. Determine the equation on 1.8. We need to determine the equation of a line parallel to KM, passing through N. All right, it is passing through N parallel to KM. All right, so this is what we need here, 1.8. So if you are to consider this on 1.8, we are given that the line is parallel to KN. All right, parallel to KM. Parallel to KM, and passes through N. We are given where it is going to pass through, which is N. Remember, N is our midpoint, that one that we used. So what is it that you're going to take? We need the equation, yes, but what is that we're going to take from the concept that the line is parallel? Why are we given that concept that they are parallel? Why? It is because they know that you are supposed to take the concept that the gradient should be the same. The gradient of this line that you want must be equal to the gradient of Km. And are we having the gradient of Km? That is K to M, this one. We never calculated its gradient, but we can determine the gradient. It's either you're going to calculate it or you can take it from the equation of Km. Remember, I said the equation of Km, if you still remember, can be written in this format where we made y the subject of the formula. So it simply means minus 1 over 5 is our gradient. Remember, m is the gradient. So meaning to say we have the gradient there. So you can calculate, there are points there. You can calculate your points, from the points. If you want to verify on that one, you can verify from the points, which is fine. All right, but already this gradient was there from the equation. You can tell your gradient is minus 1 over 5. So the gradient is the same. So from equation concept, I don't know which format are you going to take, but you can determine your equation. So I'm going to use y is equal to mx plus c. where m is the gradient to be calculated, minus 1 over 5x plus c. So to find c, which is the y-intercept, I'm going to set the point that I'm given. That is xy, y is equal to minus 1 over 5 times x, which is 1 plus c. So that is it. Y is equal to what? Minus 1 over 5 times 1, that is minus 1 over 5 plus c. So let's transpose this. It is going to be a positive 1 plus 1 over 5. That is what you're going to have at the end. And that was going to give us 6 over 5, which is equal to c. So therefore, our equation at the end was going to be equal to, on this, you just have to substitute. So this is minus 1 over 5x plus the c that we calculated, which is 6 over 5. Just like that. Just like that. So meaning to say, you ought to be very, very careful in your simplification part, because any mistake can affect everything. As you can see, this is from another part. Anything, it can be affected. So you have to be very, very careful on how you simplify. Determine the coordinates of P, the point of intersection of the line found in question 1.8 and the line KL. The equation of the point of intersection of the line found in 1.8. 1.8, the equation parallel to this. All right, so that is it there. On 1.8, remember we calculated this equation. That is the one that we just calculated right now. This is the one. Y is equal to, so I'm just going to rewrite our equation. Y is equal to minus 1 over 5x plus 6 over 5. That was our equation. And that line, so we need the point of intersection of this and the line KL. KL, we have the equation, remember, for KL, this one, y is equal to 5x plus 9. So the equation is there. Y is equal to 5x plus 9. This is the equation of line what? KL. We are already given that equation. So I said that whenever you are to calculate the point of intersection, just like what happened on question 1.1, where we are to show the coordinates of K, we calculated that using the point of intersection concept. And I said at the point of intersection, the two equations are equal. So meaning to say at the point of intersection, the two functions are equal. So we can solve simultaneously the given equations. And there we are already given y in terms of x from equation 1, y in terms of x from equation 2. So I can simply equate this y and y. They're the same. If y is equal to this and y, they're the same. These are the same. So you can equate what is on the right-hand side to what is on the right-hand side of the other equation. So minus 1 over 5x plus 6 over 5 is equal to 5 x plus 9, like that. So that's you and your equation. That's you and your equation. So depending with the side that you're going to use, let's say I want to maintain the left-hand side, remain with the 6 over 5, transpose the 9, this side is going to be a negative. It was a positive, so it's going to be a negative. So this is equal to, on the right-hand side, I'm already having 5x. On this right-hand side, there's already 5x. I transpose the minus 1 over 5 to the other side of the equation, so it becomes a positive 1 over 5. It was a negative. So on the other side, it will be a positive. So subtracting this, what are we going to have at the end? This will be negative 39 over 5 if you simplify properly on your calculator. Add 5 and 1 over 5, you're going to obtain 26 over 5x. So to obtain x, you're simply going to divide by the 26 over 5 both sides. So you divide by 26 over 5 both sides. Also by 26 over 5 both sides. Thus determining the value of x at the point of intersection. So the x value was going to be minus 3 over 2 if you divide this properly. And since at the point of intersection, the two equations or the two functions are equal at the point of intersection, we can substitute the x value that we obtained here in any of the given equation. You're going to substitute in any of the given equation. All right, so in this case, I'm going to take advantage of equation 2, where y is equal to 5x plus 9. That's y is equal to 5 times x our x value minus 3 over 2 plus a 9. Just like that. So meaning to say y is going to be 3 over 2. That's a positive. So therefore, the point of intersection P, remember P represents the point of intersection the way that you're given. Calculate the coordinates of P, the point of intersection. So P from x, y, x is minus 3 over 2. Y there is 3 over 2. So that's our point of intersection. So that's how you simply work out the point of intersection. You're supposed to be very, very careful in every simplification solving of equations. As you can see, you're back to those simultaneous equations. You are now working with the simultaneous equations there. That's it. That's it. You see how they play around there. So you just have to be careful. So that's our point P. Remember it. We might need that point. So we have to be very, very careful. We're gonna need that point. If we need that point, I mean. All right. Then on 1.10, 1 point improve that. So there it's a proof. A proof you just have to calculate when it is like this. Prove that Km is equal to 2Pn. This is all about distance. This is all about length. The length of Km, the distance from K to M, is the same as the length, 2 times length. So you just have to calculate because that is it. Guys, guys. All right, no problem. So because this video is now too long, someone is tired. Yeah. Anyways, let us see. Km, we have got the point K and M here. That is the point K and M. So you're going to calculate the distance of Km. All right, so let me just calculate it here, guys, on the diagram here, somewhere here. So I'm going to answer this question here, 1.10. So remember, we want to prove that Km is equal to 2 times Pn. So let us just use where we can see Kn. Let's start with the length of Kn. Remember, from the distance formula, we can calculate this x2 minus x1 squared plus y2 minus y1 squared. That is depending with the way that you're going to take from K and M, but what we just need are the x values there. So it's a choice. So if you're going to use this as your x2, it's up to you. 4 minus 1, it's up to you the way that you are going to take them. But that's a 4 minus 1. So it's going to be the square root of 4 plus 1. All right. 4 for x. So it was supposed to be like this, 4 minus 1 squared. So a minus, that's a positive. So that's 4 plus 1 squared plus y minus y1. So y2 minus y1. That's the y2 value, which is at this point M. That's 3 minus the y value, which is a 4. So that's 3 minus 4 squared. So that's you and your calculator there. Just make sure you simplify properly. You were going to obtain the square root of 26. That is the square root of 26 units. Then for Pn, you are going to see that we have got the point N here. N was the midpoint, remember? N, we calculated that midpoint, it was 1, 1. I still remember that one. So, all right. Also, P, we calculated P from the previous part that we just calculated now. Remember, our point P was minus 3, 2. 3, 2. That was our midpoint. I mean, the point of intersection of those two lines, the one that we solved from the previous question. And also, we have got the point N, which is the midpoint, which is 1, 1, remember? So we have got 2 points there. So you can calculate the distance just like this part that we had. So Pn was going to be the x value of the second point minus this one. So 1 minus, that's a plus 3 over 2 squared plus the y value 1 minus 3 over 2 squared. So it's going to be 1 minus 3 over 2 squared. So it's you and the calculator simplify properly. It was going to give you the square root of 26 over a 2. So that is the idea there. This is square root of 26 over 2. So let's check the relationship. This is km, which is the square root of 26, and this is pm. So if you multiply 2 pm like this, 2 times pn, that is 2 times pn, the square root of 26 over 2 like this. This will cancel. You get the square root of 26, and the square root of 26 represents what? Or represents km. So from these values that we can see, it simply shows us that truly this km is truly it is 2 times of what? Of pn, like 2m, 2 times pn, it gives us km. That is the idea there. If you can prove from this concept, you can see that you substitute this, you're going to get the square root of 26. So that is the idea there. Some of the questions, they do not need what can you say? There's no difficult in those questions. You just calculate the length as usual. You compare those lengths according to the information that you're given. Maybe it was 3 times, whatever that you'll be given on that particular question. You prove with that condition. Is it maintaining exactly the condition that you're given? If it is maintaining the condition that you're given, therefore, that's perfect. You solve the way that you can solve, that is to prove a question. So more to come from Meson African motifs till we meet again.